All righty. So good morning to everybody. I'm gonna get things kicked off here. So welcome to all that are participating today. Thank you so much for taking the time to join us this morning for our hurricane webinar. And hopefully you can hear. I can see things in the chat right now that people are saying they can't hear, and also hold off on your questions on just this minute because we're going to walk through how this webinar today is going to work. But again, thank you for joining us for this hurricane webinar in collaboration with the National Hurricane Center, who folks are there with the Hurricane Awareness Tour live from JFK Airport. Good morning to everyone. So my name is Holly Morin. I am the Manager of Education and Outreach at the Interspace Center at the University of Rhode Island's Graduate School of Oceanography in Narragansett, Rhode Island. And I'm joined today by my colleague, the Assistant Director of the Interspace Center, Chris Knowlton, who is also live from the Hurricane Awareness Tour. I am obviously not there. I am in a spare bedroom at my house in North Kingstown, but it's a beautiful day, a wonderful day to connect with those folks there live from the Hurricane Awareness Tour. And who are those individuals? So from the National Hurricane Center in New York City at JFK Airport, Dan Brown, who's a senior hurricane specialist, and then Robbie Berg, also a senior hurricane specialist. They are there on the tarmac and will be connecting with you live with a selection or a suite of other folks that will be joining them throughout the course of the day. And then we have Brad Reinhart, who's joining us. Brad, you want to give a wave? Fantastic. He's a hurricane specialist, and he's actually joining us live from the National Hurricane Center in Miami, Florida. So we've covered the whole coast almost here, the Atlantic seaboard, for this webinar, which is great. And Brad's going to be on hand to answer some questions, but also give you all a tour of the National Hurricane Center real quick, which will be fantastic, and we'll get to in a little bit. So how today's webinar is going to work. So you all are using the chat box to say good morning. I love it. That's great. That is where you're going to want to ask questions. If you have problems, technical issues, I am the host today. I will do my best to help navigate those issues and make sure you're able to experience everything. But you don't want to ask your questions, your science questions, your hurricane questions there. You're going to put those in the Q&A panel during today's program. So when you click on those three dots, the Q&A box may not be there for you right away. If you click on those three dots, it'll expand your menu and it'll give you the Q&A panel, and that's where you're going to answer or ask your questions. And we may type in answers, or we can also verbally ask them and get some answers as well. So that's where you want to put your questions so we can see them, and you want to make sure that they're going to everyone, not just myself, the host, the panelists, etc. Alrighty, so then you have the Q&A panel, and then it shows you there. You'll be able to see other questions. So maybe you see the same question that's already been asked, and you want to ask something different. And then also questions, if their answers are typed in, you'll be able to see those there as well. Alrighty, so again, this is brought to you today by NOAA's National Hurricane Center, the National Weather Service, the IAC, URI as well. So what I'm going to do now is, I love all these good mornings from all of you. Thank you so much. I'm going to stop sharing this presentation, and I'm going to flip us to the other presentation. Just give me 1 second.
You're live.
Yep.
But
hold on 1 sec, Chris. Just switching slides here. Can you all see? Nope, that one's not sharing now. There we go. Just swapping out my presentations. All righty, here we go. So what I'm going to do now is I'm going to hand it over to Dan Brown and others there live from the NOAA Hurricane Awareness Tour. Dan, I've got your first slide, just the title slide up.
Good morning, everyone, and thank you, Holly, for getting us kicked off this morning. Thanks to Chris here, who is holding the camera for us. We are here at JFK Airport in New York City this morning, and we're so excited that everyone could join us. This is part of what we call the Hurricane Awareness Tour. I'm joined here with my colleague, Robbie Berg. My name is Dan Brown, and we are both hurricane specialists at the National Hurricane Center, where we do forecasting for tropical storms and hurricanes. What are two guys from Miami doing up here in New York? We're up here again as part of this National Hurricane Preparedness Week that is running this week, where we're trying to get everyone to be ready for this upcoming hurricane season. As we know, last year we had some very devastating storms, and we're going to talk about some of those. And we're also going to be joined today by some of the aircraft crew that actually fly right into the storm. So very exciting day here, and we're so happy you could join us. Holly, if you go to the next slide, it actually shows you where we've been this week on the awareness tour. So we started last couple days. We were down in Washington, D.C., and yesterday afternoon we flew up here to New York. And so today we're going to be here meeting with emergency managers, bring school kids out. But unfortunately, we can't do that this year. So we are now going to bring this to you today live here from our awareness tour. Hopefully you're still hearing me. Okay, so then if you do the next slide, Holly, actually maybe move ahead a couple here. If you move ahead one more, Holly, it'll show you those storms from last hurricane season. So you can see it was very busy. In fact, it was the third most active season on record last year. And it was the second consecutive year that we actually ran out of hurricane names. We got to nearly the end of the alphabet with our hurricane names. Didn't have to go to this new list that we had ready to go. But again, it was a very busy year. And you can see some storms there that I'm sure were quite maybe memorable for your areas. We had Hurricane Ida that struck the Gulf Coast as a Category 4 storm. And then it moved up here in the Northeast, dumping tremendous rainfall. And then we also had Hurricane Nicholas that made landfall in Texas. So the next slide shows that where we are from, Robbie and I, we're from the National Hurricane Center. So again, greetings, from Miami. We actually have another colleague of ours, Brad, that will be joining us for a second and give you a tour of the National Hurricane Center. So we're really excited to have him here as well. And we got folks here. We got James going to join us here in a second, and George and Eric. They're from the National Weather Service. We're going to talk to them, and we're going to have folks that are going to come over and join us today. So, the thing I was going to tell you is, again, we're all part of the National Weather Service. There's actually 122 National Weather Service offices around the country. So there's one in your local area that's helping you to understand what the weather is going to be. And I'm going to ask James to come over for a second. And we're here at active runway, so we're going to print. So then it's all right. I think the plane's far enough away now. Good morning. My name is James. I'm from New York office, right here located on Long Island. And what we do is we cover a geographic area called a county warning area, and we forecast for this area in collaboration with neighboring offices, make sure we're all on the same page. We issue watches, warnings, advisories for all sorts of weather, blizzard warnings, severe thunderstorm warnings, tornado warnings. Those are some products we issue. We also collect daily and monthly climate data from around our area. So we keep track of records. One of my favorite duties that we do is the up-air balloon launch. So thanks, James. I was just going to add, when a hurricane is threatening, we are talking to James and the colleagues like him around all the National Weather Service offices, the coastal regions that could be affected by a hurricane. So it's a really close collaboration. We actually do a video call. We can see each other face to face. We can share that forecast with those local offices. And we at the Hurricane Center, we're looking at the big picture. We're really looking at the sort of a regional scale of the hurricane, and it's the local offices that are then taking that information and telling you where the storm surge might be the highest, where the various hazards are going to be.
Jump in really quickly, and we'll switch gears and sort out the audio there at the tarmac.
We're going to send it down to Brad, and we're going to see if we can get some better audio here. So, Brad, if you don't mind going ahead and letting folks know how we forecast storms, giving that tour to the Hurricane Center, and we'll be right back here to talk about the hazards in the plains.
Sure, that sounds good. Hi, everyone. Good morning. My name is Brad Reinhart. I'm a hurricane specialist here at the National Hurricane Center in warm and sunny Miami, Florida. And so actually behind me, you can see our new video wall, which is pretty cool because it shows all of the storms that we had in our forecast area last year. And I don't know if you know this, but not only do we watch hurricanes in the Atlantic Ocean, we also watch in the Pacific. So if you see that wall behind me, there's a lot of storm tracks on there. As Dan already mentioned, it was another very busy season in the Atlantic. And so it's great that we're here today talking about how we can get ready for the next hurricane season and be prepared. So we have about 50 or 60 people that work here at the National Hurricane Center. And actually during the season, which runs from June 1st to November 30th, we actually have someone here every day, 24 hours throughout the season. Doesn't matter if it's night, a weekend, a holiday. One of us is always here at the National Hurricane Center, at least. A lot of times more than one person, to watch these storms and keep you safe. So my job as a hurricane specialist is to really monitor the tropics and issue forecasts and warnings for any tropical storms or hurricanes that might develop over the oceans. So you might ask, well, how do we do this job? And so, well, I hope you like computers, because we're going to go take a quick stroll through and take a look at some of the tools that we use to do our job and forecast here at the Hurricane Center. So I'm going to set up here. So you can see behind me, we have a lot of cool technology, a lot of computers that we can look at to give us different types of data that we can use both to tell where a hurricane is and then to forecast where it might go. So if you look here, we've got satellite data. So I don't know how well you can see, but I'll zoom in there and see I'm actually looking right there at the New York area. And so this satellite data is actually taking pictures of clouds from space. So it gives us a really good idea of where the storms are forming, what they look like, and their structure. We also look at radar data. I'm sure you've seen radar data on TV before from maybe your local meteorologist on the news. Radar data just gives us a colored image of where precipitation is occurring within a storm. So it gives us an idea of where the rain is, where the heavy thunderstorms are, that kind of thing, to tell us when a storm might be forming or strengthening.
Hey, Brad, can I interrupt you really quick? Because you're talking
Yes.
about all this fantastic data. There's a question actually where Amy Rojek, her students here are asking if there was a certain characteristic that makes a location prone to hurricanes. So you're looking at this different satellite or sonar data. Are there certain characteristics of an area that will make a hurricane form somewhere there rather than somewhere else?
Yeah, absolutely. That's a great question. Thank you for it. And so, yeah, some of the conditions that we're looking for when we're trying to predict hurricane formation, obviously warm water is one of the most important ingredients that we need for hurricane formation. So we need that water to typically be 80 degrees Fahrenheit or warmer in order to support development. That warm, moist, the air that flows over the warm waters, it's that heat and moisture that goes from the sea surface up into the atmosphere that provides kind of the fuel for hurricane development. So that's a great question. And yeah, those are some of the most important factors. We also have to look at winds, not just at the surface, but also way up in the sky, because if the winds are too strong way up in the air, like where the airplanes fly, for instance, then that can actually disrupt and make the system not as organized. So yeah, these are great questions. And yeah, these are some of the data sets that we use to assess those conditions and whether or not a hurricane might form. So I'll pan here. So we also have computer model data. And so computer model data is really important because once we know what is going on in the environment, we can tell the computer model, hey, this is what's happening right now. And then we run these models and it can help us to predict what might happen in the future. So I don't know if you can see here, but this is a computer model run from Hurricane Ida last year that hit Southeast Louisiana. But you can see each one of these colored lines is a different model solution that gives us an idea of what might happen for a particular storm. And so computer model data is very important as well and helps us to make good forecasts. So we rely a lot on, look at all these computers that I have behind me. So we've got a great team here at the Hurricane Center that keeps our computers running and keeps our data flowing. Other data, the group in New York already mentioned weather balloons. So those are very important too, because they give us an idea not only of what's happening at the surface, but as the balloon goes up into the sky, it gives us an idea of what the temperature and the winds are like way above the surface where we can't easily measure it. And then our friends, the hurricane hunters, obviously, they provide us crucial information. All these tools that we can look at satellite and data that's collected from space, but nothing beats having an airplane in the storm to tell us where the center is, how strong the winds are, and what's going on. I mean, nothing beats that kind of in-person reporting that the hurricane hunters provide.
Awesome. Thanks, Brad. And real quick for you, because I know this question's been asked a couple of times now, I've seen it. Why do y'all name hurricanes? That was something that when Dan, before I took the presentation down, he had that slide that showed all the different hurricanes, and you're talking about tracking them and you're showing these different models. Well, why do you guys name them?
Yeah, it's a great question. So giving them a name makes it easier, not only for us to keep track of, because a lot of times we have multiple storms going on across an ocean at any one time. So giving it a name makes it easier to keep track of and also easier to communicate, right? So when we talk about it, when our friends on the news, Weather Channel, or other media organizations are talking about it, and make sure we're all on the same page. We're all talking about the same system, because sometimes there might be 2 or 3 hurricanes out there at any one time, and it'd be easy to get really confused, right? If they didn't have a clear name assigned to each one. So that's the primary reason. Great question.
Awesome. Thank you. It looks like they actually moved inside one of the airplanes, which is not a bad idea. So, Dan, why don't you go ahead and say hello again, and we'll see if we can hear you.
Hey, thank you, Brad, so much for taking over a little earlier than we had planned and showing everybody the National Hurricane Center. Hopefully you got appreciation of how we use all that data and those models to make those forecasts. But again, we were getting ready to talk before we left about the hazards of the hurricane and how do we know what we need to be preparing for. So with that, I'm going to turn it back over to Robbie Berg. He's going to talk a little bit about the hazards. And then, as you see now, we're actually on that NOAA P-3 aircraft that fly right into the hurricanes. And then we're going to talk to some folks here that do fly right into the hurricanes. So here you go, Robbie.
Hey, thank you, Dan. So I think Dan mentioned earlier when we were out on the tarmac that there's an acronym or a word we like to use to help people remember what those hazards are, and it's called SWIFT. So think about a hurricane in your mind. Just imagine it. What do you probably think of when you hear the word hurricane? Most people probably think about the wind blowing. The winds can be very strong. They can cause damage, destruction, blowing down trees. Unfortunately, maybe some houses and other buildings. And wind is definitely important. That's how we categorize hurricanes, from category 1 all the way up to category 5. But there are other things that come with hurricanes that we have to be concerned about. In fact, one of the major things we're often worried about is water. That people can drown in the water that comes from the sky as rain or as storm surge that comes in from the ocean. So when you look at this word SWIFT, think about S meaning storm surge, which again is that water coming from the ocean. W is wind. The I and the F both stand for inland flooding. So it's the rain that falls from the sky and then causes the rivers to swell and flood areas near those rivers. And then lastly, we have the T, which stands for tornadoes. So hurricanes can spawn tornadoes, especially in their outer rain bands as the storm is moving along. So when we're forecasting at the Hurricane Center, when our colleagues at the Weather Service office here in New York are watching hurricanes and forecasting, it's not just the wind we're looking at, it's all of these hazards that we have to be concerned about.
Yeah, thanks, Robbie. And just in the last few years, the vast majority of fatalities from hurricanes has been from inland flooding, has been the worst hazard. So again, we've got to make sure folks are staying safe when hurricanes are threatening. So I know Brad talked about the forecasting. We're going to go a little bit here and find out exactly how they collect data from this airplane. And it's so vital to us at the National Hurricane Center. And I'm going to see if Chris can walk with me here. But when we're forecasting, if we're looking at a satellite picture, we can estimate how strong a storm is. And we can look at kind of the structure of the storm. But when they're actually flying a plane in the hurricanes, which we do when they're threatening land, we can now get measurements right inside the storm. And they're doing that with a variety of instruments and sending that right back to the National Hurricane Center. So I'm going to have Nikki Hathaway, who's one of the flight directors, tell you exactly what they do. And she's a meteorologist that's on board the aircraft. So Nikki.
Thank you so much. Yeah, thanks for coming today. So essentially what I'm doing as a flight director is, of course, safety of flight is number one. So I'm working with the flight crew in the front and the scientists in the back to make sure we're accomplishing that scientific objective in the safest way possible. So besides that, all the data that's being filtered and picked up by our aircraft before it goes anywhere to the National Hurricane Center, into the computer models used for forecasting, I'm quality controlling that data. So anything that leaves the plane has been touched by the meteorologist's hands and make sure, this is the best it can be and is accurate and representative. Besides that, I'm also monitoring radar. So we have a lot of equipment. You see all the real estate here that we're looking at constantly. Your eyes are not leaving that radar screen throughout the entire process, the entire flight in the storm. So we have our MMR, which is that big black M&M-like feature you see underneath our aircraft. That's doing a lot of that operational, using that to get through the storm operationally, that as well as the nose radar. So those are the two that we're really using to navigate and pick through the storm. And then that tail Doppler radar on the back, that's really once you're in it, you know, that's what it's showing you. So you're not using that to really navigate through, but you are putting that into the computer models, which really helps with initialization.
Yeah, and a couple of things I was going to tell folks is that you're measuring wind at the flight level of the aircraft, and then there's also instruments that's on the wing that measures winds further down. Can you tell us a little bit about that?
Exactly. Oh, and both are so vital, right? And we use both for different things. So, for example, as you're going inbound, you're going through your eyewall for maybe the first pass of the storm for that day. Those flight level winds are essentially being, you know, watched and everything very closely. But the SFMR, the SEP frequency microwave radiometer, is actually deriving winds on the surface of the ocean using brightness temperature. So we're looking for that white caps, the churning of the ocean. From that, the actual instrument is able to derive a surface wind speed. And we're using that to deploy our radius of maximum wind sondes. So those radius of maximum wind sondes might be 1, might be 3, but we're using that looking for that peak. And then once the winds do reach that peak, we're deploying those sondes and hoping that we peg that, you know, max surface wind. And then once actually in the eye, we're using our flight level winds again to fix the flight level center of the storm. So we'll switch to our actual data being collected by the probes or sensors on the front of the aircraft, using those wind speeds and directions. And I'm actually calling out tracks to our flight crew saying, let's go ahead and go 330, 320, 310, hold it. Okay, our winds are coming down. One last turn, 300. Okay, navigator mark center. Let's go outbound on a track of whatever that might be. So both are really vital for the overall process.
Yeah, I don't think people realize how busy you are when you're flying into the hurricane.
Absolutely.
I'm sure it's very interesting once you break out of the eye and get to see that eye and you maybe describe that. But until that point, you're just collecting all this data, making sure it gets to us, and it gets to us very quickly. We get that data within about 5 to 10 minutes at the National Hurricane Center, and so we can make those really critical decisions. And it's so vital for the analysis of the storm, for us to know where it's located, how strong, how big the storm is, and then also I'll tell, as Brad talked about the computer models, a lot of the data also goes into those computer models, which improves those forecasts. So again, really vital. But I'm going to have you. It's really cool too. You're right here near the cockpit. And just talk about what does it feel like going into a hurricane, and also you know, what is it like being inside the eye? You get to do that so often.
Yeah, and you know, you talk about looking out the window, and really, I rely on our pilots to do that because I'm so busy creating like the board plugging to our song and we're expected it to. So I'm really in the data, even in the eye. I don't look out the window much, really. If you have any chance, it's a quick, okay, I see, you know, it's sunny again, blue skies above, terrific. You know, it's what we would expect during the daytime operations. But overall, the experience is extremely exhilarating. You're constantly go, go, go. And it's really, you know, we're maybe 6 hours in the storm environment, 2 hours for transit on either side potentially. So, you know, usually our flights are overall about 8 hours. So that's the actual storm part. But then, you know, with the briefing beforehand. So you're coming in an hour earlier, prepping the crew, making sure they know what to expect for that flight today. And then afterwards, making sure that data got where it needs to go, putting it on the server, things like that. And so it's a very long day, especially when there's multiple days in a row, right? Yeah. You're never flying a storm once, unless it's making landfall really quick. So usually this is a course of 5 to 7 days. Dorian, you know, upwards of plus 10 days. So it's a long stretch for a series, and before you know it, you're done with one storm and on to the next one, right? So the overall hurricane season can be extremely busy, and it's really the off season too. We're doing a lot of research outside of hurricane season as well.
Yeah, and that's a great point. The hurricane seasons have been very busy lately. Really since 2016, we've seen all these above average seasons. In fact, we've had more Category 4 and 5 hurricanes to hit the United States since 2017 as we did from 1963 to 2016. So really busy for you all, for us. But I want folks to realize it takes such a team to make the hurricane forecast, to get you the information back at home. You know, we met folks, we met James for the local office, Robbie and I back at the Hurricane Center, Nikki here doing the flying. We have some Air Force partners that are also here. I'm not sure we're going to make it to really get to the Air Force side of things, but they also fly into the planes. And there's another plane out there that actually flies around the storms that drops these drop zones. And we're going to go back, I think, in a second if we can get back there and show you where those instruments are actually dropped from. But they'll drop those drop zones out of the aircraft, measures pressure, wind, and temperature. And again, that information is provided back to us, gives kind of a profile of the winds in the hurricane, and also information for those computer models. So really, really vital. I was going to ask you in a second, Nikki, when we head back toward the back, maybe you can come join us, because I think we want to do some questions and answers. I know Robbie's looking at some of the questions coming in, Holly is too. So we'll get to that here in just a second. But maybe you'll give us a second to kind of walk back. And I don't want Chris to trip or run into anything, so please be careful, Chris. But again, how many folks can you get on a single flight? I know you also have some research scientists that come on board as well. So there's a variety of research that's done on this aircraft as well.
Yeah, so upwards of about 18 folks maybe max, and that's to account for both local media, like you said, our additional researchers that might be on board accomplishing scientific objectives, and the actual flight crew.
So real quick here, we may have to slide off the aircraft here in a second, but we'll see. But this is the drop zone where they actually drop the instruments right into the aircraft. And there's probably a couple of drops. I might try to grab one. I don't want to cause any problems here, but these are what the drop zones look like. So they're a little tube that is launched right out of the aircraft. There's a parachute that comes out, and then they fall down to the surface of the ocean. And as they're falling, they're actually providing us that information back up to the plane. They send it to the hurricane center about the wind pressure and humidity and storm. So again, a really neat little instrument that does go down. And James was talking about the weather balloons. They are actually launched up. So it's kind of the same idea, but one's going up and this one's going down. So really cool. And I know you also do some, occasionally they launch some unmanned aircraft, the Coyote that can fly around the storm. I think they do that here from also one of these shoots here.
Yeah, that would actually go in the free fall shoot. So our uncrewed aerial systems are becoming more prevalent, I would say, as the years go on and the technology evolves. That said, they're vital. They're able to get to parts of the storm that we can't. They're really sampling that boundary layer. So that's that area where the people on the ground are actually experiencing the weather. So things like mesoscale features, those tornadoes that spin up on that eastern side of the storm, that's what they're able to sample, and that's just not where our planes are able to go, or anyone really able to go safely. So that technology is evolving, and they've been critical with hurricane research for sure.
Well, thanks, Vicki. I'm going to send it back, I think, to Holly for a second, so that we can kind of regroup here and see what we need to be, because we got some other folks coming on board as well. So let me send it back to you, Holly, and maybe you can send a question or two to Brad while we get reorganized here, and we'll come back in a second.
Sure, I can definitely do that. And thanks so much, you guys, kind of folks that are participating. You got real lucky there that you got to have that glimpse inside one of the Hurricane Hunter planes. And yes, I know that people were like asking, is that really a plane that goes into hurricanes? And it does. It does seem big, but I was actually watching it pull onto the tarmac yesterday, and it's fairly narrow though. So it's only one seat on each side. So I know somebody actually asked a question, and Brad, I don't know if you can chime in and answer this. Somebody was asking, what's the difference then between that P-3 airplane and, a commercial plane that if students have flown before, or even whether it be a big plane or a smaller plane, depending on how far you've traveled, perhaps, what are the differences there? And I know the other question that often gets asked that we'll wait for the folks on board to get off the plane is it dangerous? And how are these planes equipped to actually go into hurricanes and collect data? But Brad, do you know more about the P-3 or the other planes that are used and how they're different maybe from commercial aircraft that folks might be more familiar with?
Sure. Yeah, I can try to answer that. So, yeah, these research planes are very interesting because from the outside, they might look like some planes you've been on before or that you see at the airport. But if you actually go inside, what did you notice when Dan was in that plane? You didn't see a lot of seats, right? A lot of the places where the seats would normally be on a commercial flight instead is where there's a lot of scientific equipment, right? Computers, different instruments that help us gather data and look at it on the inside, help our research scientists on board the plane. So that's one of the big differences. And in terms of it being like dangerous, it's, we have highly trained people that do this professionally for a living. And so their job is to make sure that it's done as safely as possible. And we've got a very, very good track record of safely flying into hurricanes and gathering this information. So I won't say that it's not dangerous because, obviously there are inherent risks anytime you get on board a plane and fly. But at the same time, we have really skilled pilots and crew that navigate around the most dangerous parts of the storm. And they know how to fly in through these storms in such a way to collect the data while staying safe.
We can ask when they're, oh, perfect. Well, they're still here. And so I think.
Yeah, so Brad did a great job answering that question, but I think we can pass it back to Nikki. We've kind of regrouped here a little bit, let some people go up to the cockpit. But they were asking about how is this flight in a P-3 different from a regular aircraft that maybe students have flown on before?
So the P-3 is flying anywhere between like 8 and 12K. So it's going directly through the eye of the hurricane, right? And so much lower level than what your commercial aircraft would be flying. So with that, the ride tends to be a bit more bumpy than what you would expect on a, a commercial airline flight. And even different too for a G4. A G4 is flying additional 10 to 15 feet, 15,000 feet higher than what your commercial airliner is doing. So the G4s out there are able to cover a lot more ground, pepper the storm with a lot more drop zones than what the P3 is doing, and really capturing that overall storm envelope. So, if there's an area of high pressure nearby or a trough access and how that might be impacting the storm and its motion, that's what the G4 is really able to capture. Versus the P3 is a little bit more focused on that core portion of the storm.
So the P3 is flying at 10K on average, and we are doing an end SON, a middle point SON, and then the RMW, the radius and maximum SONs, as well as the center SONs. And of course, it's fixing the actual center. So that's probably the biggest difference between the two aircraft.
Yeah, and Chris, I saw you get a peek, I think, of the G4 that's out here our window. The other aircraft that flies right into hurricanes is the C-130. That's the U.S. Air Force, a reserve Hurricane Hunter aircraft. You can also see that it has those propeller props, much like this plane. I don't know if you want to tell folks why you use the props versus a jet for the hurricanes, and then we'll take the next question.
Yeah, so the jet, its engines are completely different, right? So P3 has those 4 propellers, and those are really because it can handle that amount of water. So when we're going through at 10,000 feet, there is a ton of water. It almost looks like going through a car wash. And those propellers are able to withstand that. And sometimes if we do pop up a little higher in altitude, we are encountering grapple too. And so it sounds like a really, really loud metal hitting, the aluminum frame essentially is what it sounds like, or a tin roof. So it gets very, very loud, but our propellers are able to withstand a lot more of that convection and the different types of water that we encounter at our flight altitude. While the G4, when they're up there dropping their SONs and flying their flight path, they're actually avoiding areas of convection. And that's critical, right? Their engines just cannot withstand that amount of water. And even though they're up at 40,000 feet, sampling the tops of the tropical cyclone, and even part of the anticyclone at times, they're going around that stronger updrafts that might be up to 60,000 feet.
Yeah, and just for folks, the convection is those showers and thunderstorms that are surrounding the hurricane. That's where you get those updrafts and downdrafts that make your flight bumpy at times. And then also the grapple is like almost like soft hail that can hit the aircraft, and I'm sure it gets kind of loud if you run into that.
Oh, yeah.
So I think Robbie says he's got another question for Holly.
Yeah, so actually I'm watching the questions here and I see several about the drop zones, about are they recoverable, do they biodegrade? So I think a lot of people are interested in what happens to it.
Sure. So essentially what these things are designed to do is to fall to the surface of the ocean, bottom as far as it can go, and eventually get covered up by sand and break down. So that's essentially how they're actually, where they end up. And they're designed to go all the way to the ground and get covered up by sand so that no other, sea life is impacting it or getting tangled up in it, eating it, any of the sorts.
Great. Yes, we can pass to Holly if there's any other questions that you're seeing.
Yeah, so actually, this was one that was early on that can kind of go to anybody, which I always love these ones that everybody can answer. Somebody asked, I'm sorry if I don't know who it was, they wanted to know when it's not hurricane season, what are you all doing?
So Dan, the question here is when it's not hurricane season, what are we doing?
That's I get that question a lot. It's a great question. So hurricane season runs from June 1st through November 30th. So toward the December, January time period, we're actually kind of wrapping up what happened the previous hurricane season. We write reports on every single storm. We want to make sure we have that climate record so that people can look back and know where the storms were, what they did, how strong they were. So we take time to do that. We evaluate our forecast from the previous hurricane season. But then as we get kind of into the February, March, April time period, we're already looking ahead to the next hurricane season. I call it the outreach and education season because we're doing things like this. We want to get people ready for the next hurricane season. We teach emergency managers. These are folks that live in your community that make sure your community is prepared, that tell you when you need to evacuate. So we're talking with those folks, making sure they have the information they need to make those critical evacuation decisions to get folks out of the way of storm surge. So I have to say I'm actually busier this time of year often than I am during the hurricane season because we're out on the road doing things like this. And then once hurricane season comes in just a few weeks, I'll be back at the office with Brad and we'll be working on the forecast right from that forecast desk that you saw him show earlier. So it's a busy time of year for us, but that was a really great question.
So I see another question here. I think we can pass to the local guys here is what are the hazards we talked about with tornadoes? And someone from, I think it's Jenny's class, is asking, how does a tornado form?
You guys want to take that one?
Sure. So, tornadoes from a fundamental standpoint form as a result of rotation in the atmosphere. So you have to have what's called a change in wind speed with height and direction, or what we call wind shear, in the environment where storms form. Now, when we're asking questions about how it forms with a hurricane landfalling, that has to do with bands moving on shore, as Robbie and Dan mentioned earlier. And that's a very complicated scenario to forecast for because these hurricanes can generate very weak tornadoes that can be very hard to detect both visually and on radar. So it can be very hard to forecast for them. So I guess that answers that question specifically for hurricanes.
Yeah, and I'll just add that, as you mentioned, the tornadoes in a hurricane are sometimes weaker than what we get out in the Midwest, but they can still be destructive. They are more difficult to detect and put out the warning for them. But that is what the local office is doing. They're watching those radars, putting out those local watches and warnings, making sure you know what those hazards are going to be in your local area. And they're doing that year round. We at the Hurricane Center, again, we work those shifts starting May 15th, actually, because we also cover the Eastern Pacific Ocean where hurricane season starts a little earlier. But these guys are working year round, making sure your community is ready. So I think Robbie has Holly has another question for us.
Yeah, you were just talking about other areas, and we do have a question here about typhoons and tropical cyclones and how are they different. I'm wondering if Brad wants to take this one from the office.
Hi, Robbie. Sure. Yeah, I can take that. So it's a great question. Yeah, a tropical cyclone is just kind of a generic term that we use for these low pressure systems that have organized storm activity that form over the tropical oceans. So a tropical cyclone is kind of all encompassing for a tropical depression, which is a very weak system, a tropical storm, and then a hurricane as well. Once they achieve wind speeds of 74 miles per hour or greater, that's where the names get a little different sometimes. So like in our part of the world, we call them hurricanes, but in other parts of the world, like in the Western Pacific Ocean, they're called typhoons. And it's just a difference in terminology, but the storm itself is similar, or is the same really in terms of the structure, how it forms, and the wind speeds that it's producing. But when you hear tropical cyclone, that's just an all-encompassing one to not, because some tropical cyclones don't become hurricanes, right? Some stay tropical storms, or some even as tropical depressions. So hopefully that clears it up a little bit.
Actually, I'm going to chime in here because I think they're moving around a little bit, but a couple of other questions talking about where, I know a lot of people put about tornadoes and classification. I'm going to actually take a couple of questions here and combine them because that's kind of what I do. I've seen a couple of questions asking, so we're going to make it twofold, asking about all this data that you're collecting, all these different impacts that there are. How do you communicate that and work with the national, the Weather Center staff, and then get the message out to the public? And then also, what should the public then do? How should they respond? How can they be safe during a hurricane or, some other event that's associated with a tropical system?
Sure, I can take this one, Holly. Yeah, so as you've seen, there's so much data that's coming in. Sometimes it can almost feel like too much where, we're sitting here at the computers and we've got data coming in from airplanes, from satellites, radar, every which way. And so it's our job to put all that data together and use it in order to put out the best forecast that we can. Once we hit send and push our forecast products out to the world, then in terms of communication, we have people in the Hurricane Center that specialize in communicating that to the public, but also all of our information becomes publicly available once we hit send. So it goes to our website, it goes to all our friends in the news media, so your local news channel, all the way up to like the Weather Channel, Weather Nation, different cable providers. And so it's a big task that a lot of people across the enterprise, both within the National Weather Service and outside, help us to communicate this effectively to you in the public and help you make the right decisions. And so, hopefully that answers the question a little bit. I think Robbie might be coming back up now.
Yeah, thanks, Brad. We've moved around a little bit in the plane here. I did see a question about what else do you guys fly into? Bomb cyclones, winter storms. So I'm going to pass it to Nikki to help answer that. But we've also come up to the cockpit, so you can actually get to see where the pilots are flying this thing.
Mm-hmm. So that's a great question. So a lot of folks ask, what are we doing outside of hurricane season? And during the winter season, we're doing a lot of research, actually. It's actually quite busy. So we actually just got back from a deployment to Anchorage where we were flying ocean winds. It's the mission we were flying for research. And most of the time we are flying through winter storms, the same type of concept, area of low pressure, only specifically, you have their clinic features like cold fronts and things associated with this. So we will fly those. This year specifically, we were measuring sea ice thickness. So we're out there pretty much validating the satellites with the NESDIS crew out there with us flying those missions. So that's something we do during the off season. We also fly supercell research missions. So we're going to be out there in Kansas here in the next few weeks, flying Taurus. That's a mission coming up soon. So that's some of the things we do outside of hurricane season. And so we have our two pilots up here. These are the folks that actually fly us through the storm safely. Very grateful for these two folks. Megan, do you want to talk a little bit about what you do?
Yeah, so we were getting ready to fly through a storm. You know, we have our headsets on, and we're actually able to see our nose radar picture right through here. And then we're just listening for Nikki's voice on our headset, and she's giving us direction to fly through that's going to get us through the safest part of the storm.
Awesome. Brett, tell us about an experience when maybe, you know, things were a little bit more hectic, or one of your more memorable experiences.
Yeah, one of my more memorable experiences was actually my first Cat 4 hurricane, Ida. We had to pick our way through the storm to get to the center of the eye wall. And going through the initial eye wall, it was described to me, and I can now relate to it. It's like riding a roller coaster through a washing machine. The most intense rain I've ever felt and strong winds. And then once you penetrate the eye wall, you get into the center, and it's this eerie, calm sense of feeling, and you get that stadium effect where you can look all the way up and you can see the stars, and you look down and you can see the bottom of the ocean floor. So kind of a memorable experience.
Absolutely. And then the other thing I just want to mention here, you'll see is Kermit. Kermit is actually hanging there in the dashboard.
Oh, yeah.
So this specifically is N42 or Kermit. Our other P3 is Miss Piggy. And then our G4 jet out there, the high flyer, is Gonzo. And he's called that because his nose looks that way. That's because of the nose radar on board that aircraft. So, and with that, I'm going to go ahead and hand things back off here. We're going to walk forward a little bit, but I'll give you back to Dan, and he'll guide you through some more questions. Or Robbie, do you have any more questions?
Yeah, I'm trying to scan through here. Holly, have you seen anything else?
Yeah, I got a question here because I was scrolling through the top to some of the top of the list to where some folks were asking some questions a little earlier. There's actually a question asking, are you considering using unmanned aircraft or drones in the future to replace the manned flights? I know we just lost the video there, so Brad, this may come to you. But do you know if there's, I think you all actually, with the National Hurricane Center, you do use drones of some sort, but is there the thought to replace manned or crewed flights with using drones more so to reduce the risk to potential human crews?
Yeah, I can.
Do you want me to take that, or you, Brad?
Yeah, I can start. I mean, I know that there have been some, experiments and tests done with unmanned vehicles. In fact, I think maybe ask your teacher to YouTube it later or go home and check it out. But I think there was a really cool drone video. I believe it was from Hurricane Sam last year. They got some really cool footage from inside the eye of a hurricane. So yeah, there are some experiments and tests being done with unmanned vehicles. But obviously, the Hurricane Hunters still provide us a really important service as well. So I think the future, at least in the near term, it'll probably be some kind of combination of both, where we'll still fly some planes, but also, having unmanned vehicles gives us the opportunity to have data inside the storms even more often, maybe. So.
Great, thanks for that, Brad. And then another question here, which I always appreciate these ones as well. So this is from Baxter, and this can go, I know Dan Brown's backstory, so I may punt this one to him. But the question is, did you all love hurricanes when you were kids? Or did you have other favorite kinds of severe weather, other natural disasters? So is this job what you initially, wanted to set out to do? If I remember correctly, Dan Brown wanted to be a basketball player. Yeah, is this what you loved when you were a kid, and this is where you've been all the time? I don't know if Dan could hear me. But Brad, is this what you wanted to do? What was your personal journey to become a hurricane specialist?
Absolutely. Yeah, it's a question we get a lot, and it's funny because I feel like with meteorologists, so many of us know from a really, really young age that we want to do this. And I was one of those kids. In pre-K, I knew I wanted to be a meteorologist. I think I had to explain in kindergarten how to how to spell meteorologist to my teacher because I don't think she'd ever had a student before that wanted to be that. So yeah, it's something I've always been interested in, and working at the National Hurricane Center is just kind of a dream. It's a really exciting place to work, and yeah, I'm thrilled to be a part of this agency and work here.
All right, great. And then I don't know, Robbie, if you can hear me. There was a question about if, your personal journey, you and others that are on board the P3 to becoming a meteorologist or a hurricane specialist.
You want to start off with why you got into it?
Yeah, there you go. Thanks, Chris.
Hey, hey, Holly. Just back to Dan here. So yeah, I guess when I was about the age of most of you that are watching today is really when I got my passion for meteorology. Just was something that I really enjoyed following, watching. And so that really kind of what drove me into the field. And I'll tell you, to me, it's much more than a job. I really just love doing what I do. And the fact that it helps other people makes it so worthwhile. So I was going to have one final question here, and then maybe we'll go around and talk to others about how they got into the field of meteorology and if there's any advice they want to give to any of you out there. But first, I know we talked about the drop zone earlier, so I was going to ask Eric. So besides the drop, which is collecting information going down, we do the weather balloons. And so I was going to ask Eric about, when are they launched at each weather forecast office, and how many times a day, and how high up does it go?
Yeah, so that's a great question. So weather balloons are typically launched twice a day for 0Z, 0 Zulu, and 12Z. And those are to feed into the weather models. And that happens around the globe, standard times everywhere. And in severe weather or special times, we may launch extra supplemental soundings. And with the weather balloons, they are balloons. They're just giant versions of what you may find at a party store or at a birthday party. They're huge. They're filled with helium or hydrogen, depending on what office you're at. Both can get there. They lift them up, and they rise up to about 100,000 feet, and then they burst. And there's actually a parachute on them. So sometimes you can even find the radio zone in a field somewhere or in your neighborhood. And if you find those, there's instructions on how to return those to the Weather Service. But it's pretty cool, and I know that's one of the big draws to the Weather Service. People love watching the weather balloons.
So yeah, thanks, Eric. And it's interesting because they provide all that data to us, and they're launched both in the early morning and the evening hours. I know you said 0Z and 12Z. That's like what we use Greenwich Mean Time, but in the East Coast here, that's in the morning and then in the evening. So I'm going to pass the microphone around, and we'll maybe give folks, if they want to say a few words about, again, how they got into it and any advice. And I guess my advice is find something you like to do, because I think most people that get into meteorology do that. So here you go, Jordan.
Thanks, Dan. So I guess like most of us, you have a weather story that you're passionate about. Mine was actually a hurricane in 1999. Hurricane Floyd made landfall as a tropical storm in Long Island. And even at that intensity, I remember the winds and the rainfall as an 8-year-old. And then, of course, winter storms like blizzards and nor'easters got me interested. But also it's about understanding and knowing how to better communicate the science, really is what drives a lot of us. And as far as advice to all of you that are listening, I would say find your passion. Find what drives you, find what captures your interest, find what inspires you, that gets you out of bed and makes you interested about learning something more than you already understand up to this point. Find something that keeps your attention and that makes you feel fulfilled at the end of the day. That's what's most important.
And I'll just echo what you were saying. I mean, I've known since the 3rd grade I wanted to be a meteorologist. I grew up in Tampa, Florida, so hurricanes were very prevalent. I had a lot of hurricanes, like school days, we were out. I was upset. Why can't I go to school? The school bus can't take me. It was too breezy, too windy. But the advice I'd probably give to anyone who's looking to go into any sort of STEM career is don't be intimidated by the math or the science. None of us were terrific in any of our schooling. You're going to mess up. You're going to make mistakes. You might not get a concept. Maybe it's trigonometry. Maybe it's algebra. Who knows? But don't be intimidated by that, and just keep trying, because everything takes a little bit of practice. And I think, by the time you end up in your career, you'll be proud you stuck with it.
So I knew when I was younger, I was impacted by a bunch of blizzards and nor'easters. And I just loved I would get so excited for a big 2-foot, snowstorm. And it got to the point where I got so into weather that my friends started asking me, oh, what's this storm going to do? What's that storm going to do? So I started doing a little bit more research. When I was really younger, that might have just been, looking at the TV or online and just kind of relaying what I saw there. But then I really, as I got older, I started getting into it more. I started reading forecast discussions, and those can be found on your local WFO website. And I started reading them at a really young age, and I had no idea what they meant, and I was very intimidated. So I guess my advice would be, don't be intimidated right away by a lot of the terminology that we use. And there's a lot of good resources online. I know NOAA has the NOAA jet streams. There's a lot of good information on there. And so, yeah, and I really read a lot of AFDs, and I loved it. I loved predicting the weather. I loved telling my friends what I thought the weather would be. And that's how I got into it.
Yeah, I think we're about ready to run out of time, but I'll just sum this up by saying you probably noticed a theme. We meteorologists are a special bunch. We knew from a very young age what we wanted to do. And so like many of these guys have said, is if you know that's your passion, if you know you're really interested in something, go for it. It doesn't have to be meteorology. It can be oceanography, computer science, communications, anything. If it interests you now, it's probably going to interest you as an adult. So go for it.
And I'll just say that Holly and Chris, that's a wrap from here. I want to thank Chris for being our camera person today, and Holly for helping keep things going back there. And I think we'll throw it back over to you and Brad to kind of finish things up. But again, thanks everybody for joining us today.
We really appreciate that, Dan, and the rest of you on board. I think that running things from inside the P3 was a really unexpected but special opportunity for folks to be able to engage that way. And then, Brad, have you live there from the National Hurricane Center. I know that we have a third grade math class who's super excited about science, and I love to hear that students are. So yes, I'm happy to give you a shout out, Enterprise Elementary, Mrs. Donald, Miss Lowry's third grade classes. You guys keep up that hard work and keep excited and interested in science. I am not a meteorologist. I'm a marine mammal biologist by training who actually did go to Texas A&M. I saw that in there in the list of questions. So I just echo everything that everybody shared there. Is find something out that you love to do. I also put a note that said, figure out what you don't like to do. I learned I don't like looking at microscopes, and that was a very important thing for me to figure out early on. Brad, did you give your backstory? I think you did, and you were hooked as a kid to get into this?
I've always known since I was a kid. I grew up on the Mississippi Gulf Coast, so we were kind of always under the threat of hurricanes. So a couple that I remember in particular were Hurricane George in 1998, which hit like Gulfport, Biloxi area. And then I was a senior in high school for Hurricane Katrina in 2005, which was very damaging. I think somebody asked about the highest storm surge ever recorded. And Katrina had a 28-foot storm surge in South Mississippi. So it was very, very devastating. And I knew before those events, I wanted to be a meteorologist, but that really kind of solidified it for me, that I wanted to learn more about, the storms that can cause that kind of damage and help to keep people safe from them.
Brad, I love that you're an Aggie, and so am I. So this is, look at that.
Life works here. She's an Aggie too. We've got several Aggies at the Hurricane Center, actually. It's pretty neat.
There you go. And I actually was in Texas when Rita hit after Katrina. So I empathize there with that evacuation process and everything that a lot of folks went through. But thank you to everybody who took time to join us this morning. And thank you so much for bearing with us as we did have some audio and technological issues. In the end, I think this worked out really well. The webinar itself is being recorded, and there I will share really quickly. So it'll get recorded and then posted to the Hurricane Science and Society website. So that's hurricanescience.org. That you can see there. And then on this slide, there are a whole host of other websites and resources that you can then go ahead and access. So the hurricanes.gov website, that's the National Hurricane Center website. You can go to the National Weather Service. And then for more preparedness information, please check out, you can also go to hurricanestrong.org/kidsready.gov. But this webinar itself, it will be posted eventually. Give us a little bit of time to process it, maybe make it a little bit better audio-wise, add some media assets if necessary, and we will post it on that hurricanescience.org website there. And if you registered for today's program, that's how you guys all got the link, and that is how it will be shared, the link to then view this at a later time, and/or it may also get posted to the Inner Space Center's YouTube site. So a lot of different ways for folks to continue to access this information, a lot of great websites that were just shared for you to find out more. But otherwise, please stay safe this hurricane season. Thank you so much for being such a wonderful audience. Thank you to everybody on board out there at JFK, and thank you to Brad for your time today from the National Hurricane Center as well. Thanks so much, and have a great rest of your week. Bye, everybody.